Here we are on page 2 of differentiation rules. Okay, differentiate with respect to x. That's just saying take the derivative again. What do they mean by with respect to x? Well, when you only have one variable with and it's x, then it doesn't really say anything because obviously you're going to differentiate with the only variable you have. But if you have many different variables or even two variables in the expression, maybe you don't know if you should take the derivative with respect to x or y, and they need to tell you which one. If you have a variable that's not the one that they tell you to take the derivative with respect to, then you just treat that variable as a constant. You just leave it as if it was a number. Okay, so a lot of these are easy, right? Now you're getting pretty used to the power rule. So you know that 2 just becomes 0, and the 6x, when you take the derivative of 6x, you end up with 6, right? What about this one? We don't know how to do this one yet, multiplied together, but we can multiply it out, and then we know. So we multiply it out. X squared plus x minus 2x minus 2. We can simplify that. X squared minus x minus 2. And then we take the derivative, and then we'll end up with 2x minus 1. Right? And the negative 2, the derivative of negative 2 is just 0. Same thing with c here. We just multiply it out first because we don't know how to take the derivative of products yet. So we just put 25 minus 10x plus x squared. And then we take the derivative of that. We get 25, derivative of 25 is 0. Derivative of negative 10x is negative 10. Derivative of 2x squared is just 2x. And then g, finally. Let's see. So we just rewrite this so that it's 4x and negative 1/4 x to the negative 1. And then we take the derivative, and the first term becomes 4, and the second term becomes negative 1/4 x, negative 1 times x to the negative 2. And so we can simplify this. It'll be 4 minus... actually, the negatives here cancel out, so it's 4 plus 1/4, and then x to the minus 2. Okay. Find the gradient of the tangent to, and then y equals x squared at x equals 2. Now, the gradient of the tangent is the same thing as a derivative. So first you just take the derivative. The derivative of y equals x squared is 2x, of course. But then they say at x equals 2. So now you evaluate it at the coordinate x equals 2, and you get a very specific number, which is 4, right? So since they're giving you a value here, then at the very end you plug it in. If you plug it in at the very beginning, then you'll get y equals 2 squared, which is 4, and if you take the derivative of that, you're just going to get 0, which is not the correct order. You need to plug in the coordinate at the very end. Okay? So be careful with that. So we're going to take the derivative of this. Derivative of 2x squared is 4x. The derivative of negative 3x is negative 3, and the derivative of 7 is 0. So we have this derivative function, and then we plug in negative 1 for the x, and we get negative 4 minus 3 equals negative 7. So our answer is negative 7. Okay? Last of all, y equals x squared minus 4 divided by x squared. Again, we don't know how to do a quotient like this, so we just divide each term by x squared. The first one we get x squared divided by x squared, which is 1. The second term we get negative 4 divided by x squared. And then, so if we take the derivative of that, the derivative of 1 is 0. The derivative of negative 4x squared. Negative 4x squared is also negative 4x to the negative 2, right? Negative 4 divided by x squared is also negative 4x to the negative 2. I'm going to write that down here. So I'm going to rewrite the whole function, and it looks like that. And then I'm going to take the derivative. So the derivative of 1 is 0. The derivative of negative 4x to the negative 2 is negative 2 times negative 4, which is positive 8. X to the negative 3, and then I'm going to plug in x equals 4 here. I don't need to use the y value because it's irrelevant here. The derivative only depends on the x value. So I'm going to put 4 in for the x value, and I'll get 8, and then I'll have 4 and for x, and cubed. And so that gives me 8 divided by, and finally I have an equal sign here, 4 times 4 times 4, which is 64, is that right? 4 times 4 times 4, so that would be 16 times 4, yeah, 64. And that's the same thing as 1/8, so I can simplify it a little bit. Okay, moving on. Number 5. Suppose that f of x equals this function, and f of 2 equals 4, and f dash of negative 1 is equal to 2. Find the constants b and c. Okay, so the first thing I'm going to do is I'm going to find the derivative, because it says that f dashed of negative 1 is 2, so I don't even know what the function f dashed is yet, so I'm going to do that first. So it's going to be 2x, because x squared, take the derivative of x squared, it's going to be 2x. Then b is a constant, so I just treat this b plus 1 as a number. And so if I take the derivative of that, I just get b plus 1, because the x is going to disappear. Plus 2c. 2c is a constant, so that just becomes 0 also. So now I have f dash of x is equal to this, and I do know that when x is 0, when x equals negative 1, then I know that this derivative equals 2. So I can like plug all this in. I'll say 2 times negative 1 plus b plus 1 is all equal to 2, right? So then I'm going to say negative 2 plus 1 plus b equals 2. So b is equal to, let's see, negative 1. It's b equals to 3, right? Okay? So we now know that b equals 3. Now since we know that b equals 3, we can take b equals 3 and we'll put it back in there. And now we'll probably be able to figure out, what c is. So we'll have x squared plus, and b plus 1 would be 3 plus 1, which is 4x, plus 2c. And that is equal to, let's see, so that's our function. That's our function x. And we know that f of 2 is equal to 2 squared plus 8 plus 2c. We know that f of 2 is equal to 4 because it says it right there. So we know that 4 plus 8, which is 12, plus 2c equals 4. So 2c is equal to negative 8. So c is equal to negative 4. So there's our value for c. Okay. Now to number 6. Find the gradient function of f of x, where f of x is. And here, they're saying finding the gradient function. They're just saying take the derivative. Okay, so this first one here, the derivative, well, let's simplify it here. We're going to write 4x to the 1/2 plus x to the first. So that makes it a little bit easier. We can use the power rule for both. So we're going to have 2x to the negative 1/2 plus 1. Okay? And then for this one, it's the same thing as writing 4x to the negative 1/2 minus 5. The derivative of the first one is negative 2x to the negative 3/2. And then the derivative of negative 5 is just 0. So here is the derivative of that one. And then here there's a negative 2 over square root of x. We can simplify that to be negative 2 times x to the negative 1/2. And so if we take the derivative of that, it's going to be negative 2 times negative 1/2, which is the same thing as 1, and then x to the negative 3/2. Okay, and then last of all, we got this one. We'll have 5 over x squared square root of x. X squared times square root of x is the same thing as x to the 2.5. Okay, because x to the, I'm going to rewrite this to make it a little bit easier for you, x squared and x to the 1/2. So now I can add these two exponents together. I can get 5 over x to the 2.5, which is also known as 5/2, right? And then, so that's the same thing as 5 times x to the negative 5 halves, and now we can just use the power rule again. So we use the power rule, and we're going to have 5 times negative 1 half, which would be negative 25 halves, x, and then to the negative 7 halves. Okay? All right. 7a. If y equals 4x minus 3 over x, find the derivative and interpret its meaning. Okay, so let's find the derivative first. The derivative of 4x is going to be 4. The derivative of negative 3 over x, which is the same thing as negative 3 times x to the negative first, is going to be plus 3x to the negative second. And so this is going to be like y dashed equals 4 plus 3x. And interprets meaning. Okay, it's the gradient of the function. Okay, that's the meaning of the derivative. A derivative is a gradient of a function. Or you could say it's the rate of change of y with respect to x. Rate of change of y with respect to x. The position of a car moving along a straight road is given by s equals 2t squared plus 4t meters, where t is the time in seconds. Find ds dt and interpret its meaning. Okay, so again, ds dt, we're just looking for the derivative, and so the derivative is going to be 4t. We're just going to use the power rule, plus 4. Okay, and then how do we interpret this meaning? Well, we know that s is the position of the car. When you take the derivative with respect to the time, you get the rate of change of the position of the car with respect to time. Guess what? That's velocity or speed. So we'll say, oh, we're talking the speed, or we'll say velocity because it's going to have positive or negative sign. So we'll say it's the velocity. Okay, that's the interpretation of its meaning. And that's it for page 2.